Hi, till now, up to the last class, we have seen in detail about all the 12 principles of green chemistry. So, in today's class, let us see what is meant by atom economy in detail. According to the second principle of green chemistry, synthetic method should be designed to maximize the incorporation of all materials used in the process into the final product. So here only the atom economy comes. What is meant by atom economy? It is a measure of the efficiency of a reaction. Normally, when a reaction takes place, the reactants are converted into products. So after the completion of the reaction, that is towards the end of the reaction, we may be interested to see what amount of the reactant gets converted into the product. That is what is the yield of the reaction. So in doing so, conventionally what we do is, we used to calculate the percentage yield. So in calculating the percentage yield, what is the advantage, what is the disadvantage? So we will see by taking an example. Say in this reaction, butanol, it reacts with sodium bromide in presence of sulfuric acid to form N-butyl bromide, sodium hydrogen sulfate and water. So in this reaction, the main substrate is N-butanol and the product of interest is N-butyl bromide. So the sodium hydrogen sulfate and water, it becomes either the co-product or the waste product. So conventionally what we do is, we should take the reactants in the molar ratio. So if we take 1 mole of N-butanol, then automatically it should give 1 mole of the product, that is the N-butyl bromide. In this case, for example, if we take 0.8 grams of N-butanol, then we should take 1.33 moles of sodium bromide and 2 moles of sulfuric acid. Here the chief substrate is N-butanol. So sodium bromide is the reagent. So slightly we should take in excess quantity. So in this reaction, we have taken 0.08 grams, which corresponds to 0.0108 mole of N-butanol and 1.33 grams of sodium bromide, which corresponds to 0.0129 moles of sodium bromide and 2 grams of sulfuric acid, which corresponds to 0.02 moles of sulfuric acid. So here the main substrate is N-butanol, where we have taken 0.0108 mole, and the other two reagents, sodium bromide and sulfuric acid, we have taken in slight excess. So it should give the product, that is N-butyl bromide, that is the same 0.0108 mole. So that is 1.48 grams of the product we should be able to get. Then it will be 100% conversion. So the compound 1 in this case, that is the N-butanol, becomes the limiting reagent. That is, if we take 0.08 grams of the reactant, that is 0.0108 mole, then it should be equal to 0.0108 moles of N-butyl bromide. It cannot be more than that. Either it should be less or equal to this. So that is why N-butanol is called the limiting reagent. So if we get 1.48 grams of N-butyl bromide, then it is 100% conversion. Instead, if we get 1.20 grams of N-butyl bromide, then how we calculate the percentage yield is, so it is a ratio between the actual yield to the theoretical yield into 100. Here the actual yield is 1.20 grams, whereas the theoretically, that is 0.0108 moles, means it should be 1.48 grams. So the ratio between these two multiplied by 100, it comes round about 81%. So if we calculate the percentage yield in this fashion, so something is missing in this reaction. Let us see what are all the things we are missing in this method. So we may not know what are all the addition products formed, how much of waste is generated. If the waste is generated, whether the waste is benign waste or the co-products benign, or it can be reused. And if so, how much energy is required or purification steps needed. Then what are all the solvents used? Even if solvents are used, whether they are benign and whether they can be reusable. Is it a catalyst used? If it is a true catalyst, whether we are taking it in a stoichiometric quantity or in a catalytic quantity. So these informations are missing in this type of calculation. So if we take atom economy as the measurement, that is as a measure to measure the efficiency of a reaction, then what is atom economy? The percentage atom economy is equal to formula weight of all atoms utilized to the formula weight of all the reactants multiplied by 100. So here, to do this, we may need a balanced equation. So we may have to take what are all the additional reagents, what are all the additional products formed. So it focuses on all the reagents. So we may know what is the stoichiometry of the reaction and how efficient is the reaction in practice. What are all the solvents involved? How much energy is involved? So let me explain you the strength of the atom economy. Let us take this reaction, that is epoxidation of an alkene using a peroxy acid. Let us take styrene as the main substrate, and when it is treated with metachlorobenzoic acid peroxy acid, so the main product, it will be styrene epoxide. Here the yield will be 100%. So in this case we may not know what is the additional product formed. So if we see the stoichiometric equation, so in addition to the styrene epoxide, metachlorobenzoic acid is the co-product. So if we calculate the percentage yield, the percentage yield for the epoxide will be 100%. And the percentage yield for the metachlorobenzoic acid is 100%. But if we talk in terms of the atom economy of metachlorobenzoic acid will be 70%, whereas the atom economy of the styrene epoxide will be 30%. It means more than 70% of the material goes into waste. Now let us see how the atom economy works for different reactions. So generally reactions are classified into 4 types: substitution reaction, elimination reaction, addition reaction, and rearrangement reactions. So we will take one by one and see that is how the atom economy is determined, how it works out. Let us take the same example where we have taken it to explain the percentage yield. That is N-butanol reacting with sodium bromide and sulfuric acid to form N-butyl bromide, sodium hydrogen sulfate, and water. Basically, it is a substitution reaction. The hydroxyl group present in the N-butanol has been substituted by bromine. So that is why the product is N-butyl bromide. So if you try to calculate the atom economy, what we have to do is, so if you see the table, in the first column we have entered the reagents formula. That is C4H9OH, sodium bromide, sulfuric acid. So these are all the reactants used in this reaction. In the adjacent column the reagent's formula weight we have written. In the next column, the utilized atoms. What are all the utilized atoms? That means what are all the atoms it goes into the product. And the next column, that is formula weight of the utilized atoms. And subsequently in the next two columns, what are all the unutilized atoms and what are all the corresponding weight of these unutilized atoms. So if we see in total, so the total reagent formula, that is 4 carbon atoms, 12 hydrogen atoms, 5 oxygen atoms, bromine, sodium and sulfur. And if we add the formula weight of all these atoms, it comes to about 275. And under the utilized atoms, if we see with respect to N-butanol, 4 carbon atoms and 9 hydrogen atoms, it enters into the product. With respect to sodium bromide, only bromine atom goes. In case of sulfuric acid, none of the atoms enter into the product. So if we calculate the formula weight of the utilized atoms, so in the case of N-butanol it will be 57, in case of bromine it will be 80, and totally it works out to be 137. So if you try to calculate the percentage atom economy, which is a ratio between the formula weight of the atoms utilized to the formula weight of all the reactants multiplied by 100, it goes like this, that is 137 divided by 275 into 100, which is equal to 50%. So the percentage atom economy will be 50% in this case. So we have seen this reaction, and to measure the efficiency of the reaction in terms of percentage yield, it comes to about 80%. But whereas if we talk in terms of atom economy, just it comes to 50%. See the difference. Now let us take an elimination reaction as an example. Say tertiary butyl bromide. It reacts with sodium ethoxide to form isobutylene and ethanol and sodium bromide. So here we have eliminated an ethanol molecule from the reactants. So it gives isobutylene as the product. So if we try to calculate the atom economy as we have done for the previous substitution reaction, here the formula weight of all the reagents, it comes to about 205. But whereas the total utilized atoms, that molecular weight or the formula weight, it comes to 56. So if we calculate the percentage atom economy, that is 56 divided by 205 multiplied by 100, it works to 27%. Now let us see in case of an addition reaction. So as an example, we are taking isobutylene as the substrate. To this we are adding hydrogen bromide to form tertiary butyl bromide. Here in this reaction, we have indicated no peroxide is present. That means during the addition reaction, it has to follow the Markovnikov's rule. That is, the hydrogen atom of the reagent, it should go to the carbon atom of the double bond, which is having more number of hydrogen atoms, and the bromine atom, it has to go to the other carbon atom. So in this case, it gives the product tertiary butyl bromide. Even if the reaction takes place in presence of a catalytic quantity of the peroxide, then the reverse addition takes place. In that case, the product will be isobutyl bromide. Okay, whatever be the product. So if we calculate the atom economy, the reagent formula, that is isobutylene, it is C4H8, and hydrogen bromide HBr. The formula, corresponding formula weight is 56 and 81. So in this case, butylene C4H8, the entire mass, it goes into the product. Similarly, all the hydrogen bromide what we are taking in the reaction, it goes into the product. So ultimately the total reagent weight is 137, the product weight is 137, and if we calculate the percentage atom economy, it will be 137 divided by 137 into 100, which is 100%. Now let us take a rearrangement reaction. So in this example, we have taken 2,2-dimethylbutylene, and that in presence of an acid, it gets rearranged into an isomer. That is, the CH3 group gets shifted to the adjacent carbon atom, and in turn the double bond comes to the next carbon atom. So here the total formula weight of the reactant is 84, and that has been totally rearranged. That is, nothing is added or nothing gets eliminated. So the total product weight is also 84. So if we calculate the percentage economy, it will be 84 divided by 84 into 100. Once again, it is 100%. So far we have seen the atom economy calculations for a substitution reaction, elimination reaction, addition reaction, and a rearrangement reaction. What we infer out of all these calculations? That is, if we do a substitution reaction or an elimination reaction, the atom economy will be less. And if we do an addition or rearrangement reaction, the atom economy goes to 100%. So while designing a reaction, so we should see to that the reaction will be either addition or rearrangement, so that no waste product is formed, and if no waste product is formed, no question of removal or polluting the environment. So to understand much more about the atom economy, let us take one more example, that is formation of ethylene oxide. So let us take two routes. In two different methods, let us prepare the same ethylene oxide and let us see how the atom economy works out. In the first method, which is called chlorohydrin route, let us take ethylene that reacts with chlorine in presence of water to form beta-chloroethanol. Subsequently, it reacts with calcium hydroxide to form ethylene oxide, calcium chloride, and water. So if we calculate the atom economy, so here the total formula weight of all the reactants, it will be 189, and the formula weight of all the products, it will be 44. So if we calculate the percentage atom economy, it will be 44 divided by 189 multiplied by 100, which is equal to 23%. So in this method, the atom economy is 23%. Now let us see the alternate method to prepare the ethylene oxide. So this is the catalytic route for the preparation of ethylene oxide. In this catalytic route, ethylene, it reacts with oxygen in presence of a catalyst to form ethylene oxide. So ethylene, it totally reacts with oxygen. That means both ethylene and oxygen completely they go into the product. No waste product is formed in this reaction. So the formula weight of all the reactants, it is 44. The formula weight of the product is 44. So the atom economy is 44 divided by 44 into 100, which is equal to 100%. So if we evaluate these two methods, that is by the chlorohydrin method and by the catalytic route method, the catalytic route method to form ethylene oxide, it is much more efficient than the previous method. So where the atom economy is 100%, there is no wastage is generated in this reaction. So that means we need not bother about the polluting the environment. Now let us try to understand the concept of atom economy by taking an industrial process, that is the synthesis of brufen, which is an anti-inflammatory drug. So in the classic route, it was developed by Boots Company Limited. They prepared the brufen from isobutyl benzene. In the first step, it undergoes acylation with acetic anhydride and aluminum chloride to form the corresponding acetyl product. In this step, the waste products are HCl, acetic acid and aluminum hydroxide waste. Then in the second step, it reacts with chloroacetic acid. Subsequent hydrolysis, it forms the corresponding aldehyde. So in these two stages, acetic acid and hydrochloric acid, it goes as a waste. Then the aldehyde, it reacts with hydroxylamine to form the corresponding hydroxylamine product, which subsequently it gets dehydrated to the corresponding nitrile. This nitrile finally on hydrolysis, it forms the brufen. So here ammonia goes as the waste product. So this is the method which was developed by Booth's Company Limited, and we will see how the atom economy is calculated if we do this particular process. So if we calculate the atom economy for this particular process as we did for the other examples earlier, here the total formula weight of all the reactants, it comes to about 514.5, whereas the formula weight of the product is 206. So the atom economy is 206 by 514.5 into 100, which is equal to 40%. So that means 60% of the product, it goes into the waste. So the wastage removal become a problem, and further it may not be that viable process. And if we take the second route, that is closest route for the synthesis of brufen, so here also we are taking the same isobutyl benzene as the starting material, and it gets acylated in presence of hydrogen fluoride and acetic anhydride. So here it is differing with the earlier method, that here we are using hydrogen fluoride and in the previous method we are using aluminum trichloride. Here the waste product is only acetic acid. Then subsequently it is catalytically reduced in presence of hydrogen and nickel to the corresponding secondary alcohol, which further undergoes a catalytic reaction, that is carbon monoxide in presence of palladium, to form the brufen. So in this process the wastage is less. Further, if we calculate the atom economy, the total reactant formula weight comes to about 266 and the product, it is 206. So the atom economy is equal to 206 by 266 into 100, which is equal to 77%. So if we compare these two industrial processes, the hottest process becomes economical. The atom economy is 77%, much higher than the earlier method. So this will be more economical and it will pollute the environment to a lesser extent. Hope you understand what is meant by the atom economy, how to calculate atom economy, how it differs from the percentage yield, and how it varies depending upon the reaction. So in the next class we will see how to design a safer synthesis. Thank you.